In this video session, we are discussing collection framework from Module 2, Subject, Advanced Java and J2EE. In this slide, we will discuss the different types of map classes which are available in the collection. In the previous slide, we have seen the different map interfaces. Similarly, we can see different map class. So first one, there are several classes provided by the map interfaces for the implementation of map interfaces. So first one is an abstract map. The abstract map is a class which is going to implement the map interface. Means for these classes, all the methods of map interfaces are available. Enum map is a class which is going to extend abstract map and implement the map interfaces. Again, the enum map is also having the map interfaces method. Then hashmap. Hashmap is a class which is going to extend the abstract map class for the making use of an hash table. So again, this is having the map interface methods. So tree map is a class which is going to extend the abstract map in order to perform the operation as tree. So weak hash map is a class which is going to extend abstract map class to use an hash table with weak keys. Linked hash map is a class which is going to extend hash map class to allow insertion order iteration. In what order we have inserted, the same order we are going to retrieve it. In that case, we will make use of a linked hash map. Identity hash map. Identity hash map is going to extend abstract map class and make use of reference equality when comparing the document. These are the different map classes which are available in the map. So the first class is an hash map class. The hash map class is going to extend the abstract map and implement the map interfaces. The hash map class is mainly used to store the value in based on hashing tables. This allows the execution time for get and put to remain constant even for the large set. So execution time of the hash map is better when you are going to perform get and the put when performing an operation with large set of the values. The hash map is a generic class. Its declaration is shown below. So class hash map key and value k and v, where k is going to specify the type of the key and v is going to specify the type of the value that hash map should hold. And the different types of the constructors which are available in the hash map class are the hash map with empty argument, no argument, then hash map with one argument, that is map interface, hash map with an capacity, hash map with an capacity and fill ratio. The first constructor takes the work with a default hash map without any argument. The second constructor is going to take a one argument of a map interface object. Means that I can store the value of a map interface object into the hash map class. The second constructor is an hash map which is going to take the capacity as an argument. Here I can specify the size to the hash map. Even though we have specified the size to the hash map class, still the size can go dynamically increasing. The size is not going to be fixed. As and when the elements are going to be added, the hash map size goes dynamically. But we are initializing the capacity to the hash map class. The next constructor is hash map size with capacity and fill ratio. The fill ratio, the value should be between 0.0 to 1.0. Assume I have initialized the capacity size as a 2 and the fill ratio size as a 0.5. As soon as the two elements have been added, when I am trying to add a third element, then the capacity of the hash map size is going to be increased by changing a 2 into 0.5, that became as a new capacity to the hash map class. This is how the fill ratio will be work. The fourth constructor of the hash map will be work. The first constructor is a default hash map. The second constructor is going to initialize the hash map by making use of an elements of n. The third form of initializing the capacity to the hash map. The fourth form of initializing the both capacity and the fill ratio of the hash map by using its argument. The meaning of capacity and the fill ratio is same as said. This is a simple example for the hash map class. Hash map we are created with a key as an string type, value as an integer type, where m is an object, and we are made use of an empty argument. So first default hash map constructor we are used. With the help of input method, I am adding a value to the hash map class. So where k, b, c and d are the key, 100, 200, 300 and 400 are the value which have been assigned to the hash map class. When I say system.out.println em, I am going to see the what are the values which are stored in the hash map. Okay, these are the values which are stored in the hash map class. Then m.get. The get is a method which is going to retrieve the value associated with the specific key. Now, what is the value associated with the specific key? A is nothing but 100. So here I am getting the value as 100. IsEmpty is a method which is going to check out whether the hash map is an empty or not. If it is an empty, the method is going to return a true. Otherwise, the method is going to return a false. By right now, it is not an empty, so method is going to return a false. Similarly, I can make use of another method like get values, get key, contains key, contain value, and all the methods which are available in the map interfaces. Those methods can also be used by hash map class. So next class is an tree map class, which is going to extend an abstract map class and implement the navigable map interface. The use of the tree map class is used to store elements in a tree structures. The tree map class provides an efficient means of storing key and value pairs in sorted order and allows the fast retrieval of the elements from the tree map class. The tree map class guarantees that its elements will always stored in an ascending order. The tree map class declaration is given below. Class tree map with two attributes k and v, where k is going to specify the type of the key to be held and v is going to specify the type of the value to be held by tree map class. There are four different types of constructors which are available in the tree map class are tree map class with empty argument, tree map class with the one argument of type comparator, tree map class with a one argument of type map interface, tree map of one argument with a sorted map interface. The first constructor which is always going to hold an empty tree map set, and second tree map which is always going to hold and make use of a comparator class, where the elements are going to be compared between the one another within a tree map class. And the third type of the constructor is it is going to take a one argument of type map interfaces, where the elements of one map interfaces are going to be stored in a tree map interface. And fourth one is an one argument, that is a sorted map interfaces, where the elements are going to be sorted in an order, ascending order. Even though if you are making use of an empty tree map constructor, the elements which are been assigned to the tree map class are still it is going to order in an ascending order, because it is going to make use of an sorted map interface as well as a navigable map interface concept. So here the comparators is in third form, which are initializing the tree map with entries from m, which will be sorted by using a natural order of keys. The fourth form utilizes the tree map with entries from sorted map, which will be stored in the same order as sorted map interface. These are the different types of the constructor which are available in the tree map class. Also, tree map class is going to throw in different types of exception like class cast exception. The class cast exception will be an occur when we are going to perform operation with an incompatibility between the object, and it can also throw an exception as null pointer exception when null pointer exceptions are being generated when you're going to perform the operation with a null object or null values. and illegal state exception is also going to be generated when you're going to perform an operation with an invalid argument. There are different exceptions where the tree map class are going to be thrown. Let us see in one example by making use of a tree map class and the methods of an navigable interface. This is a simple example of making use of a tree map class. Here the tree map class are being created with the key as a string and value as an integer, where m is an object of tree map class, and here we are making use of an empty argument constructor or default constructor of tree map class. By making use of an put method of map interface, we are going to be adding the value to the tree map class. So here A is 100, B is 200, C is 300, D is 400, 100, 200, 300, 400, all are the values. A, B, C, D, all are the keys. Then I want to see the values which are available in the tree map class. For that we are making use of an object of tree map class. When I use an object of tree map class within an SFP, I am going to get the values which are assigned to the tree map class. And remember that even though if I not stored in a proper order, the elements are going to be sorted in ascending order based on the key values. But in this case, I have stored the value in ascending order. Even if you not store in an ascending order, the tree map itself is going to sort the element in ascending order based on the key. The next we are using a floor key, the method which is belonging to the navigable map interfaces. The floor key is a method which is going to return the largest key of the specified key value in the method. So in this case, the largest key value of the specified method is C. So I am going to get a value as C. Then head map. The head map is a method which is going to retrieve all the element of above the specified key values. That is B. For the B, which is then above the head value is A, including the B. Why we it is displaying including the B means here we are specified as an true. If I not specified the true means I should get the value only as an A. This is an head map which is belongs to the navigable map interfaces. Same thing, head map is also available in a map interfaces, but in map interfaces we have only one argument, that is B. It says it returns the value all the above the value of in B, not including B, the head map which is belonging to the map interface. But here we are using two arguments. One is a key, another is a boolean value. When I say true, including the key value, the above the all elements are going to be get displayed. That is the reason I am getting an 100 and the value as it is. So this is a simple example for tree map class. So next class is an linked hash map class. So linked hash map is a class which is going to extend the hash map class and is going to implement the map interface. The linked hash map which is going to maintain the linked list of entries in the map means the order the values have been inserted, the same order the values are going to be get retrieved. That is, it says it maintains the linked list of the entries in the map in the order in which they were inserted. This allows the insertion order iteration over the map. When iterating through the collections view, the linked hash map, the elements will be written in the order in which they were inserted. What I told, what order the elements have been inserted, in the same way the elements are going to be retrieved by making use of a linked hash map. The linked hash map is a generic class and its declaration is given below. So class linked hash map, again key and values are the two attributes which are passing to the argument as a linked hash map, where key is going to specify the type of the key where linked list to be held, and V is going to specify the type of the value which are associated with the key for the linked hash map should hold. There are different constructors which are available in the linked hash map are linked hash map with empty argument, no argument constructor, the linked hash map with one argument, that is a map interface, the linked hash map with one argument, that is a capacity, and linked hash map with two argument, capacity and the fill ratio, the linked hash map with the three argument, capacity, fill ratio and boolean order. These are the different types of constructor. The first constructor says that it should always going to hold the default linked hash map. The second form is used to initialize the elements of the map interfaces. And the third form of the linked hash map is we are going to assigning the capacity to the linked hash map. Even though if you are assigning capacity to the linked hash map, the linked hash map size goes dynamically as and when the elements are going to be added. Still we are initializing the some minimum capacity to the linked hash map. And the fourth type is linked hash map with capacity and the fill ratio, where the fill ratio the value should be between 0 to 0.0 to 1, but the default value of the fill ratio here is 0.75. So even though if I not specify the capacity, the default capacity will be considered as in 16 and the fill ratio will be considered as in 0.75. So as and when the elements have been added, the capacity goes on multiplied with the fill ratio, then that is become as a new capacity to the linked hash map. That is making use of fourth constructor with two argument, capacity and fill ratio. The next last constructor is a capacity, fill ratio and order. So capacity is a 16, initially 16, and fill ratio is the default value of the fill ratio is 0.75. Then order, it should be either true or false. If the order is a true, then we are going to access the order, access order will be used. Means the same order what we are going to use it. If the order is a false, then insertion order will be used. Means if I make a order as in false, then I can retrieve the value in what order the values have been inserted. If I make use of an order as in true, then we can make use of an accessing the elements in between in a way. This is a different types of the constructor which are available in the linked hash map class. Similarly, the linked hash map class is also throws an exception. What exception which has been thrown by the other map classes like hash map classes. So a different type of exception which has been thrown by the hash map class are class cast exception, null pointer exception, illegal state exception, number format exception. These are the different exceptions which have been thrown by the linked hash map class. We'll see the one example of making use of a linked hash map class. So this is a simple example of making use of an linked hash map class. Here the linked hash map class has been created with two arguments. One is integer and string, where key is being created of type integer and the value is being created of type string. And we are making use of an empty linked hash map constructors. So even though I have not initialize any size capacity to the linked hash map, it will be considered as a 16 because the 16 is a default initial capacity to the linked hash map. Then with the help of input method, I am going to adding the values to the linked hash map where the key values are 100, 101 and 102 and its corresponding values are A, B and C. With the help of input method, I am going to add the value to the linked hash map class. After adding the element, if I want to see the values which are available in the linked hash map means, then make use of an object of the corresponding linked hash map class. Then here what we are doing, we are making use of an contents key. The contents key is a method which is going to check out whether the key is available in the linked hash map or not. If it is available, the method is going to return true. Otherwise, the method is going to return a false. Now it is going to check out 100. 100 is available in the given linked hash map class or not. Yes, it is there. 100 is available. So this method is going to return a true. So I am getting a true. So next we are using an entry set method. The entry set is a method which is going to point to the entry set of the given elements. So entry set of the given elements is start from 100, 101 and 102. So the return value will be assigned to the map.entry where M1 is pointing to the 100, first element of the linked hash map. Now in order to get a key which is pointed by the map.entry method, we will make use of a method called getKey. The getKey is a method which is going to retrieve the key value which is pointed out by the map.entry method. So map.entry method is pointing to the first element of the linked hash map class. So getKey is a method which is going to return the key of the first element. The key of the first element is 100. So I am getting the 100. And the get values. The get value is a method which is going to retrieve the value which is pointed out by the map.entry class, map.entry method interface. So here I am getting the value as A. So I am getting the value as A. So NS for loop is going to be continue till it is going to reach to the null of the linked hash map class. So we will get the output as 101, B, 102 and C. At the end, if the for loop, nth for loop is going to be get terminated. This is a simple example where the get key, get values, entry set, put methods have been contents key. Similarly, we can make use of an content values method, get method, other methods which are belonging to the map interface. We can also use it in the linked dash map class. So this is a simple example making use of linked hash map class along with an map interface method. So next class is an identity hash map class. The identity hash map is a class which is going to extend the abstract map class and implement the map interface. Means again the identity hash map will make use of a map interface methods, and it is similar to the hash map method. The identity hash map is similar to the hash map method, and except that it uses reference equality when comparing the elements. So here we are making use of an equality when we want to compare the two elements. Here we will make use of a concept called as reference equality when comparing the element. The identity hash map is a generic class that its declaration is given as class identity hash map key and value, where k is going to specify what type of the key to be stored and v is going to specify the what type of the value can be assigned to the identity hash map class. And the different constructors which are available in the identity hash map class are identity hash map class with no argument. This is a constructor which constructs new empty identity hash map with default expected maximum size is 21. Even though if you not specify any size, it is going to take a default maximum size is 21. But still the identity hash map is sizes goes dynamically as and when elements are been added. But this is a maximum size which has been assigned default. So identity hash map with one argument, that is the expected maximum size of int. So this constructor which is going to construct new identity hash map where empty identity hash map with specified expected maximum size. So here similarly here I can specify this size, maximum size I can specify. If I not specify the maximum size, by default it will be considered as 21. Next, identity hash map with one argument called as a map interface object. So this identity, the third type of constructor which is used to containing the all the key and values of the map interfaces which has been invoked by the identity hash map. So this constructor constructs a new identity hash map containing key and values mapping in the specified map interface. These are the three different interface which are available in the identity hash map class. So this is a simple example of making use of an identity hash map. So here identity hash map has been created with two argument. One is a key with an string and value with an integer, and making use of an empty identity hash map. Even though if here we are not specify any size to the identity hash map, but it is default it is considered as a 21 size. So with the help of input method, I am going to adding the value to the identity hash map. The key value is Ram, Sham, Amar, Anu and Priya, and its corresponding values are 343 and so and so. So here what I am doing means again we are making use of an entry set to perform the iterator operations to get all the keys and value. Already we have explained about this one. The entry set is a method which is going to point to the entry element of the identity hash map class. So entry set method can be used any map interfaces, and the return value will be assigned to the set interface. Now set is also pointing to the entry point of the identity hash map class. So with the help of an iterator, I want to iterate all the elements which are available in the identity hash map one after the another. For that we'll make use of an iterator method. So iterator method is also going to is assigned to the set interface method, and the return value will be assigned to the iterator interface. And iterator interface having a different method such as hash next method, next method. The has next is a method which is always going to check out whether the elements is available in the iterator list or not. If the elements are available in the iterator list, then the method is going to return a true, otherwise the method is going to return a false. So when you're going to retrieving the more than one number of an element, then has next method should be always written within the looping concept, so that I want to retrieve all the elements which are available in the collections. So as next method is going to check out the first key, the key is then available, so the method is going to return a true. Then we are making use of a next method. The next is a method which is going to retrieve the value, then point to the next element. Here we are making use of a typecasting to convert entry iterator concept to the map.entry concept, map.entry interface. So iterator interface to map.entry interface typecasting has been done, and the return value will be assigned to the ME. Now ME is going to pointing to the first elements of the hash link class. So in order to get a key, we will make use of a method called as a get key method. The get key is a method which is going to return the value which is pointed out by the map.entry interface. So here the map.entry interface is pointed to the first element. So its key is in RAM. So I will get a output as RAM first. Then the get value. The get value is a method which is going to retrieve the value which is pointed out by the map.entry interface. So here the value is in 34434. Its value is going to be get retrieved. This process will be repeated till the all the values has to be fetched out. This is making use of entry set and iterator interface. Next, what we are doing here, I want to retrieve the only single values. To retrieve the single value, we make use of a get method. The get is a method which is going to retrieve the value of the specified key. The value of the specified key RAM is a 3434. That value has been retrieved out and it is displayed in the balance variable. Then we are going to putting the value again with updating the new amounts. So key value is in RAM and its balance was at 3434 plus 1000. Total it should become a 4434. So we are updating the value. So we can retrieve the value, we can modify the value. That can be done by the map interface. Here we are updating the values. Then when I use again get of key, I am getting the what exactly the value which has been assigned to the RAM after updating it. So here we will get a new balance after updating it. This is a simple program where we are making use of a map interface method, map.entry set methods, and iterators methods. So next class is an enum class, enum map class. The enum map class is a class which is going to extend abstract map class and implement the map interface. Means again we are making use of an map interface in the enum map class. It is specially used for with the keys of enum type. The generic class of the enum declaration is given as enum map key extends enum key as well as values, where key is going to specify type of the value that enum map class should be hold, and v is going to specify the type of the value that enum map class should be hold. So key must be the extent of enum key, which enforce the requirement that the key must be the of enum type always. The enum map defines the different constructor. The enum map with one constructor of class type, enum map with one constructor with map key, enum map with another constructor called enum map argument, map class argument. So first constructor is going to create an empty enum map of types key. The second constructor which is going to create a enum map that contain the same entry as an enum maps interface folder. The third one creates a enum map initialized with the value of enum map interface. Means here in third constructor we are copying the value from one enum map to the another enum map. Here we are copying the value of a map interface value to the enum map class. Here we are going to specify the type of the enum map class we are going to use it. These are the three different types of the constructor which can be used in enum map class. So this is a simple example for making use of an enum map class. Here we are using a first type of then constructor, passing a class type as an argument to the enum class, and its argument type is a string type. So here we have created the enum class, which is consisting of the days Monday, Tuesday, Wednesday, and Thursday. This is an enum class. So now this enum class would be passed as an argument to the enum map class. So for that enum map class, we are going to make use of an argument called as a class and its type string. So we are creating an object as map. So I'm going to put a value with the help of an input method. So d dot Monday is an key and its value is an 1. This Monday is belong to the enum class, so I want to retrieve the value, the members of the enum class. For that we are making use of a class name of enum. So date dot Monday is a key where the value is assigned to the 1. Same thing, days dot Tuesday is a key where the value is assigned as 2. Days dot Wednesday is a key where the value is assigned as 3. Days dot Thursday is a key where value is assigned as 4. In this way, we are making use of an enum map class with the first argument as class type. Then here same I am making use of an entry set. What I already explained, the entry set is going to point to the first elements of the enum map class. Then the return value will be assigned to the map dot entry interface. And to get a key value, we will make use of an get key method. To get a value, we will make use of an get values method. When I say m dot get key, I am going to get a first this one key value is Monday and its corresponding value is 1. We am getting the value. This process will be repeated till all the values are going to be get fetched from the enum map class. So I will get Monday, Tuesday, Wednesday, and Thursday. This is a simple program by making use of an enum map class with first argument of constructor. So next topic is about comparator interface. We have seen that comparator interface has been passed as an argument to many collection classes. Now we'll see how the comparator interface is going to perform an operation and how that is going to compare the elements with from the collection within the collections. So comparator interface is used to order the objects of user defined class. So both tree set and tree maps are store elements in sorted order. What we have discussed in previous tree set class and a tree map class is always going to store the elements in an ascending order. However, the comparator that defines what sorted order means. The comparator is a generic interface that its declaration is given as interface comparator T, where T is going to specify what type of an object is going to be compared. The comparator interface defines two methods. One is compare method, another is equal method. The equal and the compare method both are the methods which are available in the comparator interfaces. We are just overriding the compare method and equal method. So the compare method is shown here. It compares the two elements for the order. So int compare object 1 and object 2. This is an override method of the comparator interface. It is going to compare the first element with the second element. Here the object 1 and object 2 are the objects which are going to be compared. This method returns true. This method returns 0 if both the objects are equal. Otherwise, the method is going to return a positive value if and only if the object 1 is greater than the object 2. Otherwise, it is going to return the negative value. Means if object 1 is less than the object 2, then the compare method is going to return a value. Return value of the compare is 3. 1 is 0 when both are equal. Another is positive 1 when object 1 is greater than object 2. Another is negative when object 1 is less than object 2. These are the three return values of the compare method. This compare method is belonging to the comparator interface method. Just we are overriding the methods. Then by overriding the compare, we can alter the way that objects are ordered. For example, to sort in reverse order, we can create comparator that reverse the outcome of comparison. So another method is called as an equals method. The equal is a method which is used to check whether both the objects are equal or not. If both the objects are equal, the method is going to return a true. Otherwise, the method is going to return a false. Here the equal method shown here test whether the objects equal in invoking the comparator. Now what the object I have passed here, whether the objects are equal with invoking the equal comparator method. If both are equal, the method is going to return true, otherwise the method is going to return a false. The object is the object to be tested for equality. So here obj is an object to be tested for the equality. I want to test with another, whether it is equal or not. This method returns true if the object is match, otherwise the object is going to be, otherwise it is going to return a false. The overriding equal is unnecessary. The most simple comparators will not do so. Let us see an example of equals and comparator method in next slide. So this is an example where we are making use of an comparator interface concept. So here the class comparator has been created. We are implementing the comparator of type string. This is an interface we are implementing, and this is a method which are available in the comparator. We are just overriding that method. We can see here annotation at override method, and we can define user define what the operation I want to do. So here the compare is also a compare to is an also a predefined method which are available in the comparator. So what I'm doing is we need to compare A with an B. So before going for this one, let's say execution is begin from main, where we are creating a tree set class of type string, and here we are using an argument constructor as a comparator constructor we are using. So for tree set, the comparator constructor is going to be get invoked as soon as the elements have been added. So here A, B, C and D are going to be passed one after the another. A is there, then A, B, C and D and D. These are the values which are going to be assigned to here, and the initial value will be A. Now it is going to compare A with and compared to B. Now A is greater than B. A is greater. A is compared to with a B. A is small, so you will get as a negative value. So we will get a negative value. So our result will be, we'll get a B. What is the value? It is holding B. Okay. If both are equal, it is going to return. Again, in first cases, we are getting the B. So next, it is going to compare C, A with a C, then A with a D. The process will be repeated. This will be a reference value, and this will be a comparison value of all the other elements. This is how the comparator is going to be performed. But here we are making use of a tree set concept, means always the elements are used in the ascending order. Okay, when you go into perform operation with an ascending order, then comparator is not much suitable. These are the reference which have been referred in the entire slide. The textbook is Albert Stead Java, the complete reference 7th edition, Tata McGrail and Jim Cook, and reference book are Daniel Lang, Stephens and Uttam K. Roy. These are the textbook which are going to be referred.